Hello, and welcome to today's conversation on pH Matters. We're here to talk about the foundation of every flock, the litter. My name is Cherie Lasota, and I'm joined by three gentlemen with diverse expertise in litter management. We're going to talk about the biggest challenges in litter management and what you can do to get your flock to maximum success. Welcome, Casey Jones, Dr. Joey Bray, and Kirk Owens. Gentlemen, please take a moment and introduce yourselves.
My name's Casey Jones. I'm a national sales manager for Jones Hamilton.
My name is Joey Bray. I'm technical service representative, and I do the tech service work across the country for Jones Hamilton.
My name is Kirk Owens. I'm the application manager, just wherever needed, whenever needed, whatever state.
Oh, wonderful. Thank you guys for being here today. So now let's talk about litter, and we're going to start at the end. So when a flock leaves, what can you do to set the next flock up for maximum success?
The first thing that you need to do is assess your litter moisture. So by going in and determining how much moisture you're dealing with, then you should set yourself up to do many practices. First and foremost, remove as much of that moisture as you can. There's several different ways. You can go in and decake or crust that litter. That physically removes the moisture from the litter. Secondly, if you decide to windrow, you need to make sure you have enough moisture there to make the windrowing process heat up enough. Beyond that, I would highly recommend that you close the houses up. So in today's technology, we have most of us use negative ventilation. And so by doing that, we can close the houses up. What we would do then is pull a negative pressure. So we're pulling more air out of the house than we're ever bringing in. By doing that, that creates a water pump. And so we can take that water and physically remove it from the house through the ventilation. What that also helps with is retaining litter heat. So keeping the heat of the litter, keeping the litter warm and keeping the air warm inside the house will then allow for moisture to be volatilized out of that litter. So those are some of the main things that I would focus on right away.
And the key is right away. The day the birds leave the house, they need to start assessing and determining what they're going to do to set themselves up for success on that next flock.
Some people talk about litter tilling. Is that something that you would recommend?
I would never till my litter. When you do that, you're just aerating it, breaking up anything that has the opportunity to release. I don't think that's a good practice.
I agree with Kirk, because as I just mentioned, we want to remove moisture. Tilling primarily just incorporates it back into the litter. So we're actually retaining moisture, which moisture is our enemy when it comes to the litter. And so we want to make sure we're removing as much of that moisture as possible to get to the acceptable litter moisture level.
Another downside of tilling is you are breaking up your carbon source, your bedding material. You're creating more surface area, and it will create more ammonia and more challenges, more moisture availability for bacteria to grow. There's really not much good to talk about when you talk about
it
tilling.
will allow ammonia to release all the way from the pad through the litter. And if you don't till it up and aerate it, you can kind of hold that down.
So that's preparing far ahead of time. So now we're a few days out. What are the best things that growers can do to set themselves up for success, when a flock is about to arrive?
So one thing you always want to do is you want to make sure you've got good preheat. I mean, when you're preheating, you're purging ammonia out of the house. You have the opportunity to pull it out of the house so it doesn't eat on your litter emitter. Because if you have all that ammonia racing through and we're there holding it down with our product, we're just using it up. So preheating is really important.
I agree. Few days out, I would make sure your litter's good and level, and then prepared and ready for your litter amendment application. The preheat is critical. By raising the temperature of that litter, we're going to actually release ammonia. That's less challenge for your litter amendment when that is applied. And so making sure that we set ourselves up for success and to create longevity of the product is a big key. The other thing that I would make sure you do is ventilate. So ventilation is going to keep moisture levels down inside the house, in the air, and be able to remove as much of that before that litter amendment goes down as well.
Preheating, I know a lot of people don't like to do it. People, they see dollar signs going out the door when you're talking about preheating, ventilating during the downtime. But to me, people need to understand that you have a finite amount of ammonia in that litter during your downtime. That is the only time you don't have a source adding some kind of
Nitrogen back to the litter.
that is going to create more ammonia throughout the flock. So that is your only time to get rid of that ammonia you have there. Keeping that house warm, closing it up, preheating before the birds get there, that is expelling ammonia that you won't have to deal with in the next flock. So it's critical. Not only that, those chicks do not have the ability to regulate their own body temperature. So when you put them on a cold floor, it's liable to be too moist because you didn't preheat. And although the air temperature in the house may be at 85 degrees, the floor is still going to be cold. Those birds are not going to perform to their maximum genetic potential because of the environment they're being placed in.
That's right. They're going to be worried about keeping themselves warm versus going and eating and drinking, getting off to a good start like we want them to.
So let's talk a little bit about litter amendment application. So I know we talk a lot about applying before bird placement, but ammonia can't always be managed just through that first application. When do you recommend applying additional litter amendment through the grow out, and why?
I believe there's a couple scenarios where a mid-flock litter amendment would come in to be very valuable. One, right now the industry is seeing a lot of very short downtimes. And like I've talked about, there's so much ammonia in there during the downtime. And if you have a short downtime, you don't have the time to get rid of a lot of that ammonia. You don't have time to get rid of a lot of that moisture. Any litter amendment is going to do so much. If you have a greater amount of ammonia than a litter amendment can take care of at the beginning of the flock, you might find yourself 10 days in with a high amount of ammonia again, and it might be necessary to go in and do a mid-flock application. On top of that, you might have a disease challenge, enterococcus, dermatitis. There's several of them out there that you can
lower the pH balance of the litter and basically take the challenge away from the bird. You know, a lot of people don't use litter amendments in the summer because they think of it only as ammonia controlled. By not doing it in the summer, you're missing out on your pH reduction, which gives the birds challenge by having high ammonia. So, I mean, there's a lot of things to look at versus not using it in the summer just for ammonia control. The pH reduction is very valuable to them. And same way with the mid-flock. By doing a mid-flock, you're holding the pH balance down and making it, you know, where the birds are not successful to get the diseases.
Yeah, these bacteria cannot replicate and survive in a lower pH below a 4. And so when you're able to go back in, when you have a dermatitis challenge and you lower the pH again with a litter amendment, then you reduce that challenge and the birds can perform to their maximum potential without having to deal with that bacteria.
What about spot treatments? Are those appropriate in certain situations?
They very well can be, especially in a dermatitis situation. When you're picking up mortality that you know is shedding the bacteria, it's very common and a very useful technique to go in and treat spots where those birds are lying. If you know you have a hot spot in your house as far as a disease goes, go in and treat that area and minimize your cost of doing that as well.
So looking a couple weeks into grow out, what are some of the biggest challenges that you see as it relates to the litter, and what are some of the things growers can do to be proactive about managing those?
I think the biggest thing that I see in several weeks into the flock is usually high levels of moisture. That leads to high levels of ammonia later on and potential disease problems. A lot of the times, to be proactive, you need to do some of those things before you ever place birds, like remove as much moisture as possible. 20 to 25% litter moisture is where you need to be before you place birds. A lot of the times they're putting birds down on 30 to 35% sometimes. So they're already at a level that's dangerous to the birds, and then you're adding more and more moisture from that bird every time, or all the days that they're in there. So being proactive and getting that moisture out if you can prior to the birds coming in is going to be very advantageous. The second thing that I would mention is aggressively ventilating towards the early part of the flock. Minimum ventilation is meant to remove moisture. And so we reach a level in the flock or a time in the flock when birds are adding more moisture than we can remove from the house. And when we reach that level, we're already, behind the 8 ball, or we already have trouble of basically getting all of that moisture out of the house. So if we can remove a lot of moisture early, that's less that we have to deal with later in the flock.
How do they know if the moisture is high or the pH is high or the ammonia is high? What can they do to assess that?
There's several methods. If your ammonia is high, your pH is going to be high. Of course, there's meters out there where you can go and take a sample and add some distilled water to that and test your pH. But majority of all the houses we've ever tested without a litter amendment is going to be at a pH around 8 to 9. And if you've got high ammonia, you have high pH. What was the second question?
For moisture, how do they test for moisture?
So for moisture, there's a couple of different ways. The most common way is the squeeze method. Pick up a handful of litter, squeeze it. If you open up your hand and that litter breaks open, stays in your hand but breaks open, doesn't ball together, you're generally below 25% at that point and you're doing well. You're below the upper threshold of the litter moisture. If you squeeze it and it balls together and sticks together, you're already above that 25% and approaching closer to 30 or 35%, where we start to see litter cake together. So that's one common way of doing that, very easy. Another good way is there are some digital moisture meters. They're not completely accurate, but they'll get you within a few percentage points of where you're at on your litter moisture. And the good thing is it'll show you exactly what that litter moisture is, so it'll give you a number to go off of. As far as litter moisture, keep in mind anytime you have excess litter moisture or as your litter moisture raises, so does your pH. So as litter moisture goes up, so does pH. So therefore that equates to more ammonia, more bacteria challenges as well.
I want to talk a little bit about windrowing. There's a number of differing opinions on windrowing. So what are the main tips that you would give people to ensure maximum success for that process?
I would start off with doing a couple of things. To determine if I'm going to windrow, first I want to go in and assess my litter. What I mean is basically I want to look at, do I have enough carbon source there? So we need 25 to upwards of 30 parts of carbon for every 1 part of nitrogen. That carbon is a limiting source. The carbon is needed for the bacteria to feed off of and utilize for nutrients. And if we don't have enough of that, we're not going to feed those bacteria the proper way to be able to get to the temperatures that we need. The second thing that I would do, and to remedy that, what I would do is bring in some new carbon periodically, maybe once a year, maybe once every 2 years. Bring in some new carbon to make sure I keep that carbon source up. The second thing I would do is assess my litter moisture. So we've got to have quite a bit of moisture, 30 to 40% of moisture in the litter to be able to really get effective temperatures. Generally at the end of the flock, you'll probably be close to that 30% or maybe even up higher. But if we don't have enough moisture, my recommendation would just be don't windrow. The problem with that is if you build a pile, you don't reach your maximum temperatures for the length of time, you're potentially setting up an environment that the bacteria actually like. So you could be breeding bacteria or increasing your problems versus getting rid of those problems. So if you don't have enough litter moisture, simply don't windrow. If you have too much litter moisture, at that point I would remove some prior to building the windrow piles. Another thing that I would mention is make sure you monitor your temperatures. Again, I ask growers all the time that are windrowing, I said, do you monitor your temperatures? If they tell me no, then I say, simply, why are you windrowing? How do you know you ever were effective at windrowing? Again, we could be setting up environments that are conducive for those bacteria versus getting rid of those bacteria. So if we're not monitoring temperatures, simply don't do it.
The methods of monitoring your temperature, there's a couple, and there's a way to use your temperature.
Yeah, so one of the easiest ways to monitor temperatures of windrow piles, of course, is a forage or soil type probe, a long probe that we can stick into the pile that will give us the temperatures of that pile. Those are not always readily available and people don't want to invest in those. So a very easy way to do it is if you have an environmental control unit in your house, take one of your temperature sensors that is utilized on that environmental control unit and stick it into your pile. What I've seen customers do, they'll take a piece of PVC pipe or something solid, they'll zip tie a temperature sensor to it and push that into the pile. Those temperature sensors will monitor that temperature for you. A lot of our growers nowadays have the technology to monitor that on their phone or from a distance, and so now they can constantly monitor their temperatures and know when it's time to turn that pile or bust that pile open.
So what is the temperature range you're looking for?
Looking for at least 131 for at least 72 hours. That's kind of your threshold. If we get to that 120, 125, sometimes we can actually be causing bacteria to grow versus reducing those bacteria. So we want to try to make sure we get to that 130 to 131 and go over that for around 3 days for each cycle.
All right, I want to talk about ammonia and what it's costing growers that they may not be aware of. And from a performance point of view, from a health and welfare point of view, and also just from an equipment, environmental and worker safety point of view, what do you see being the true cost of ammonia?
Well, I can just say, I can talk from experience of a trial that I did in the field in the summertime where a lot of growers don't feel ammonia is enough of a problem to use a litter amendment or to be concerned about. So we did a test it was in the middle of the summer in Texas. The temperature was like 115 outside. But even at that point, it got cool enough at night for the main ventilation, the tunnel ventilation to go to min vent. And during those temperatures at night, being in the low 70s, high 60s, the ammonia got up to 30 to 40 parts per million on those baby chicks. The difference in the houses that had a litter amendment that the ammonia did not get up on those baby chicks was startling, the difference. It was, the feed conversion was better, livability was better, the flock performed so much better when they did not have an ammonia challenge at those first 1 to 3 days. So that's been my experience of how detrimental ammonia can be on baby chicks.
And that's just in the summer.
And that was in the
That's just
summertime.
in the summer.
Yes.
Yeah, from a health standpoint, we try to use the threshold of 25 parts per million. But even below that, we can start to have health effects on those birds. And so, to Casey's point, even low levels of ammonia at night, when those young chicks that are only maybe 2 to 3 inches tall are in a zone where that ammonia is coming out of the litter, that young naive chick is being exposed to lots of ammonia. So from a health standpoint, we can't get those chicks off to a good start if we put them in an environment that's filled with ammonia. So by suppressing that and keeping that down, the bird will have a better time getting off to a good start, building immunity, and getting off to a healthy life from that standpoint.
What do you see, Kirk, from the point of view of the equipment? So in a house, what does ammonia do?
Well, you want to make sure, of course, ammonia rusts things the same as everything else. I mean, a lot of people want to shy away from litter amendments because it could be corrosive when it gets wet or whatnot, but everything in a house is corrosive. But like they were talking, that baby chick is right down there on that litter. I mean, he's 2 or 3 inches tall. You can walk in that house, 5 or 6 foot tall, and it's not seem so bad. But if you was right down there on it, you would see the difference in the ammonia. And ammonia causes lots of problems. I mean, throughout the flock. It's one of the biggest things we try to get away from is to control the ammonia. So.
Yeah, ammonia is harmful to your equipment, particularly in the house. A lot of the times when we shut up houses between flocks and we don't ventilate. And so what happens then is we start seeing condensation build up. And with that, when you start mixing ammonia and water together, we're creating a corrosive acid that basically can sit on your equipment. And at that point, start to rust out your equipment, tear up your feed lines, your drinker lines, things like that. So a lot of the times, the litter amendment has the ability, of course, to corrode things, but more damage is mostly done by improper ventilation and moisture buildup in these houses with high levels of ammonia in between flocks.
I think they've covered it.
And gentlemen, thank you so much for your time today. It's been great to talk to you because we all know how much pH matters in poultry.
Absolutely. Thank you.